It finally happened. Over 5 years ago I accidentally dropped this power supply and Rotary Encoder broke to pieces. I made a temporary fix by installing an old used Rotary Encoder which wasn't even the right type. It was dirty and worn. It sometimes made multiple pulses at once and sometimes didn't do anything. It was horrible, but I got used to it. Today it finally stopped working. As another temporary fix I have made a Rotary Encoder emulator. This is an Arduino based circuit with 2 buttons and 3 output wires. Output wires connect to pads where the Rotary Encoder used to be, and I can click a button and device will think I rotated the Rotary Encoder. This video is sponsored by PCBWay.com. Whether you need custom PCBs, 3D printed parts, CNC machined parts or more, you can order them from PCBWay.com. Can your own 3D printer print stainless steel? Probably not, but PCBWay's printers can. And if you need electronics modules, you may find them in their module store section as well. For all your prototyping needs, go check out PCBWay.com. You may ask why I made this Rotary Encoder emulator instead of just buying a correct Rotary Encoder and replacing it. That is probably what I will eventually do, but problem is amount of different available Rotary Encoder types. Some variables when choosing Rotary Encoder include shaft shape, physical size, spacing of the pins, detents per revolution and pulses per revolution. Luckily pinout is usually the same. Center pin is common, A and B are the ones next to it. If knob can be replaced and original one doesn't have to fit, shaft shape doesn't matter. Physical size and spacing of the pins are easy to check, even if the original Rotary Encoder doesn't work anymore. That leaves 2 uncertain variables, detents per revolution and pulses per revolution. Usual variations include ones where these values are the same, or number of detents is twice the number of pulses. If number of detents and pulses are the same, one click will cycle through this whole pattern, in one direction or the other. If there are twice as many detents as there are pulses, one click will cycle half of this pattern, ending up in a state where either both pins are high or both pins are low. Depending on how device is programmed, wrong type of Rotary Encoder will either trigger 2 steps with 1 click, or 1 step on the device requires 2 clicks on the Rotary Encoder. I can programmatically change which type this emulator emulates. Not only can I use this circuit as replacement for the Rotary Encoder, I can use this to determine which type of Rotary Encoder I need to buy if I want to replace the original. Let's look at the schematic. As an input I have 2 buttons connected between GPIO pins and ground. I'm using internal pull-ups on the Arduino. Then the output. I wanted this to be reusable, so I can use this with many different devices if I need to. So I don't know for sure what voltages are present at the Rotary Encoder's pins. I'm powering this circuit using Arduino's USB port and outputs are isolated using optoisolators. 2 GPIO pins are used, both with their own optoisolator, and the optoisolator's output sides are not connected to anything on the Arduino, as they are used for isolating the output. Collector of the first optoisolator is connected to Rotary Encoder pin A. Second optoisolator's collector is connected to Rotary Encoder pin B. Emitters of both optoisolators are tied together and connected to Rotary Encoder's common pin. This assumes common pin is connected to ground in the device and A and B have pull-ups. It's very rare to see Rotary Encoder on the high side, with common connected to voltage and A and B having pull-down resistors. So hardware side is done and it's time for the Arduino sketch. Like always, it starts by defining names for used I/O pins, couple of timing variables, and like I said, I didn't add external pull-ups, so I had to enable them for the buttons. As a starting point, both outputs are low, which means optocoupler's output won't conduct. In the main loop, I'll just read if each button is pressed and if enough time has passed since last registered press. If so, emulated step is triggered. Direction is based on which button was pressed. Order in which the A and B will toggle depends on which direction I want to emulate. Whether each pin toggles once or twice depends on which type of Rotary Encoder is emulated. Twice if amount of pulses and detents per rev are the same, once if there are twice as many detents as pulses. Main goal was to get this power supply running again. Secondary goal was to find which type of Rotary Encoder I'll need. Done and done. I can continue with my other projects. See you next video. Thanks, bye.